morning, students. In this lecture, I am going to solve problems on Fourier Sine Transform. What, students? Fourier Sine Transform. Let us see the problem, students. Find Fourier Sine Transform of f of x that is equal to 1 by x into x square plus a square, x square plus a square, and hence deduce cosine transform of 1 by x square plus a square, 1 by x square plus a square. Solution, students. Solution. What is given function, students? F of x. So given f of x that is equal to 1 by x into x square plus a square, x square plus a square. Now what he says, students? Find Fourier sine transform. So write down, students, Fourier sine transform of f of x is, students, Fourier sine transform of f of x is fs of s that is equal to integral 0 to infinity f of x sine sx dx, or students, sine sx dx. Now fs of s that is equal to integral 0 to infinity. What is f of x, students? What is f of x? 1 by x into x square plus a square into sine sx dx, into sine sx dx. So this is 1, students. This is 1. Now see, students, in such cases like 1 by x into x square plus a square, or e power x square into e power minus x square by 2, in such cases we have to done differentiate with respect to s, students. What, students? Differentiate with respect to s. So write down, students, differentiate 1 with respect to s, students, with respect to s. So we get here, what time, students? Here d by dfs by ds that is equal to integral 0 to infinity 1 by x into x square plus a square into, whenever we differentiate with respect to x, students, whenever the d by ds take inside of the integration, it will becomes dou by dou s, students. Please remember, students, dou by dou s into sine s x into dx, because we have sine sx, students, cos s term here we have. Okay, that is equal to integral 0 to infinity 1 by x square plus a square in dou by dou s, students. Come on, tell me. Cos sx into, again derivative of sx is with respect to s, students. So get x here, students. X into dx. This x cancel, students. X cancel. So this is 2, students. This value is dfs by ds. So this is 2. Again we have like 1 by x square plus a square, students. 1 by x square plus a square. Again differentiate with respect to s, students. What, students? Differentiate with respect to s. So differentiate to with respect to s, we get, what, students? We get, come on, tell me, students, d by ds of dfs by ds. We get here d square fs by ds square, that is equal to integral 0 to infinity 1 by x square plus a square into, this time, students, derivative of cos x, students, cos sx. We get here minus sine sx, or, students, minus sine sx, and again derivative of sx is x, students, x into dx. So that is equal to So students, we have x here. I want to rearrange the terms here, students. I want to rearrange the terms here. So minus, we write outside, integral 0 to infinity, integral 0 to infinity. Here we have x, students. So x divided by, what we have, students? X square plus a square, x square plus a square into sin sx dx, sin sx dx, students. Now I want to multiply with here, students, x by x, students. What, students? X by x. So x by x, students, into x. Okay, students, x by x. Now what happens, students? This one is x square, students. So x square. Now denominator contains plus a square, students. So I want to adding and subtracting a square. Adding and subtracting a square, students. So plus a square minus a square, plus a square minus a square, students. Now you separate the terms, students. Separate the terms. See, students, here minus of integral 0 to infinity. Tell me, students, x square, x into x, x square. So x square plus a square, consider as the one term, students. So divided by x into x square plus a square, and also multiply, students, sin sx. So sin sx dx minus, we have minus here, students, minus integral 0 to infinity, integral 0 to infinity. What time, students, here? Minus integral 0 to infinity. You have a square by x into x square plus a square into sin sx dx. What, students? Sin sx dx. Now we need these two equations, students. So I want to write here. So what is first equation, students? Fs of s, that is equal to integral 0 to infinity 1 by x into x square plus a square into sin sx dx. Say this is one, students. Now what is second equation, students? dfs by ds, that is equal to integral 0 to infinity. What is the two, students? Cos sx by x square plus a square into dx, students. This is 2. These two we need, students. Let us continue, students. Here x square plus a square cancel, students. So we get here, that is equal to minus bracket integral 0 to infinity sin sx by x, sin sx by x into dx minus integral 0 to infinity, integral 0 to infinity. Now see, students, here integral 0 to infinity, say 1 by x, you write a square here, students, a square. Now 1 by x, see, students, 1 by x, x square plus a square, sin sx dx, sin sx dx, students. So this can be written as, students, fs of s, students. What, students? fs of s. So a square into fs of s, students. Bracket close. Now we know one result, students. The result is integral 0 to infinity sin sx by x dx, that is equal to pi by 2, students. What, students? Pi by 2. So this value is d square fs by ds square, that is equal to, this value is pi by 2, students. So multiply with minus, students. So minus pi by 2, minus pi by 2, minus into minus plus a square fs of s, students. A square fs of s. Now you transpose to the left hand side, students. We get here, that implies d square fs by ds square minus a square fs, that is equal to minus pi by 2, students. Minus pi by 2. Now tell me, students, this is like d square y by dx square minus a square into y, that is equal to constant. It is like linear differential equation. What, students? Linear differential equation. So what is complete solution, students, here? What is complete solution? That is equal to complementary function plus particular integral, students. What is complete solution here? Complementary function plus particular integral. So complementary function, students. Complementary function. Now what is symbolic form here, students? Symbolic form. Symbolic form. That means you write in terms of d, students. So d square, because we have d square, so capital D square. Capital D means students d by ds. Okay, students, d by ds. D square minus, here we have a square into fs of s, that is equal to minus pi by 2, students, minus pi by 2. Now you write auxiliary equation, students. Auxiliary equation means you equating this quotient of fs is equal to 0. That means here d square minus a square is equal to 0. That implies d square is equal to a square, students. That implies d is equal to plus or minus a. Or, students, d is equal to plus or minus a. Now what is complementary function here, students? Complementary function c1, okay, e power minus a s, students, because we have d by ds. So e power minus a s plus c2, come on, tell me, students, e power a s. C2 e power s. This is the complementary function. Now particular integral, students. Particular integral is here 1 by d square minus a square into minus pi by 2, students. Minus pi by 2. See, students, minus pi by 2 into 1, students. 1 means it is, say, e power 0. Here actually 1, students. When we get 1, students, e power 0. E power 0 value is 1. So whenever it is e power 0, replace d by 0. So we get here minus, here we have minus here 1 by a square into minus pi by 2. So minus into minus plus, so we get a pi by 2a square. So we get a complementary function and particular integral, students. So complete solution for, students, fs. So fs of s, that is equal to complementary function c1 e power minus as plus c2 e power as plus particular integral, students, pi by 2a square. This is the solution, students. Now we need to find c1 and c2 values, arbitrary constant values. For that, say this, I want to find d by ds of fs of s, students. Fs of s. So differentiate, students, with respect to s. We get here minus e power minus as derivative e power minus as into minus a, students. So minus a c1 e power minus a s. Similarly here, students, a c2 e power a s. Constant, student. Constant value is 0. So this is 3, students, and this is 4. This is 3 and this is 4, students. Fs of s is 3 and d by ds of fs of s is 4, students. 4. Now for finding c1 c2 values, I put s is equal to 0, students. S is equal to 0 in 1 and 3, students. 1 and 3. What is 1, students, here? Fs of s, that is equal integral 0 to infinity 1 by x square plus a square sin sx dx. Now what is 3, students? Solution. Because why I am taking 1 and 3, students? Because we have fs of s here and here also we have fs of s. fs of s. So here fs of 0 students, fs of 0, that is equal to, substitute 0 students here, 0, e power 0 1, so c1 plus c2 e power 0 means 1, so plus there is no x to s students, so pi by 2a square, pi by 2a square, that implies c students here, fs of 0, s value is 0 students. In 1 here we have s students, I substitute sine 0, sine 0 value is 0 students, so this value is 0, so we get here 0, that is equal to c1 plus c2 plus pi by 2a square. Again put s is equal to 0 and compare 2 and 4 students, 2 and 4. Why I am comparing 2 and 4 students? Now you can guess, because we have here d by ds fs, there also we have d by ds fs. Okay students, right. Now s is equal to 0, that means d by ds of fs is equal to fs at 0 students. That means we can put here s is equal to 0. Cos 0 value students 1, cos 0 value is 1. So I can write here students integral 0 to infinity cos 0 value is 1, so we get here 1 by x square plus a square into students into dx, that is equal to a value is, s value is 0 students, so we get a minus ac1 plus here students e power 0 1, so ac2. Now I want to find here this integration value students, so integral of 1 by x square plus a square students, 1 by a tan inverse x by a students, tan inverse x by a, between the limits 0 to infinity, so 0 to infinity, that is equal to minus ac1 plus ac2. Now substitute upper limit students, 1 by a into tan inverse infinity minus lower limit tan inverse 0, so that is equal to minus ac1 plus ac2, 1 by a tan inverse infinity students. We get, when we get tan inverse infinity, when pi by 2, tan inverse 0 students 0, so that is equal to minus ac1 plus ac2. Say this is 5 and this is 6 students, 5 and 6. So 5 multiply with a students, 5 multiply with a plus 6 students, plus 6, because here minus a c1 plus a c2, here c1 students only, so multiply with 5 with a students, a. So we get here common element students, that implies ac1 plus ac2, that is equal, I want to transpose this right hand side students, that, so we get here minus pi by 2a square. What is 6 equation students? Minus ac1 plus ac2, that is equal to pi by 2a square, adding students, ac2 plus ac2, so we get here 2ac2, that is equal to students, cancel students, so we get here c2 value is 0, whenever c2 value is 0 students, c2 value is 0, see students, c2 value is 0 here. What is c1 value students? c1 value minus pi by 2a square. What students? c1 value is minus pi by 2a square. Now substitute in 3 students, in 3 we get fs of s, that is equal to c1 value students, c1 value minus pi by 2a square e power minus as ct value 0 students, plus pi by 2a square. Taking common pi by 2a square students, we get 1 minus e power minus as. This is our Fourier sine transform of given function students, given function. Now let's see students, and hence deduce cosine transform of f of x square plus a square. See students, second one. What is students? Deduce cosine transform of students. Say let phi of x that is equal to 1 by x square plus a square students. What is cosine transform students? Cosine transform, Fourier cosine transform. What is Fourier cosine transform students? Cosine transform f c of s that is equal to integral 0 to infinity f of x cos sx dx. So that is equal to integral 0 to infinity. What is f of x students? 1 by x square plus a square cos sx dx students, cos sx dx. That is equal to see students here, see these two, integral 0 to infinity cos sx by x square plus a square cos sx by s square plus a square. So what is the value students? D by ds of fs. What students? D by ds of fs of s. What is fs of s value students? What is fs of s value? Here students, fs of s. So d by ds of fs of s students, pi by 2a square into 1 minus e power minus as. So that is equal to pi by 2a square, derivative of 1 is 0. So e power minus as is e power minus as into minus a students, into minus a, minus into minus plus a cancel students. We get here pi by 2a e power minus as. This is the Fourier cosine transform of 1 by x square plus a square. Okay students, once again students, whenever given such type of functions, you differentiate with respect to s students. Yes. Okay students, and then simplify it. Finally you got here the Fourier sine transform of given function. Whenever he given like this students, hence deduce that means we are using this result students, this result. Okay, from this result we get the solution students. Hope you understand. Thank you for watching this video. Jai Hind.